Good day, everyone. My name is Chua Hui Wen. My group members are Zhang Weiyan, Lim Xiaoyi, Yap Chong Yun, and Shani Liu. Today, I'm going to talk about subtopic 5.1.2, compare and contrast directed graph and undirected graph, and also weighted graph and unweighted graph. Definition of directed graph and undirected graph. These are the examples for directed graph. Directed graphs are graphs that have edges with direction. Edges are the connections between objects. The edges in directed graph can be only in one direction, and the direction is assigned to the edge connecting two vertices. Undirected graph. These are the examples for undirected graph. An undirected graph is a graph that contains a set of objects called vertices or nodes that are connected together. All the edges are bidirectional. Bidirectional means functioning in two directions. For example, loops. There is no arrow and direction being assigned in an undirected graph. The writing of edge for directed graph and undirected graph. Directed graph. The order of the vertices are written according to the direction of the edge. BA and AB represent different edges. Undirected graph. The order of the vertices written is not important. Both pairs of vertices AB and BA represent the edge AB. In degree and out degree. The out degree of a vertex V is the number of arcs with V being tail. Similarly, the in degree of a vertex V is the number of arcs with V being head. For example, the in degree of A is 2 and the out degree of A is 0. The in degree of D is 1 and the out degree of D is 3. To calculate sum of degree, you have to list out all the in degree and out degree, then add them together. But for simple graph, you can use this formula to calculate sum of degree, which is sum of degree equals to 2 times the edges. Compare and contrast directed graph and undirected graph. These are the examples for directed graph, and these are the examples for undirected graph. Directed graph is a graph which a direction is assigned to the edge connecting two vertices, whereas undirected graph is a simple graph or a graph with loops and multiple edges drawn without any direction being assigned. Directed graph use arrow to represent the flow of a certain process, but undirected graph uses arcs to represent the edges. Directed graph contains ordered pairs of vertices, whereas undirected graph contains unordered pairs of vertices. Compare and contrast weighted graph and unweighted graph. There are a value or a weight in weighted graph. The edge in weighted graph represents distance between two cities, whereas the edge in unweighted graph relates information like tree map. Weighted graph and unweighted graph. A weighted graph is a graph where each edge has a numerical value. The numerical value is known as weight. An unweighted graph is a graph where the edge does not have any cost or weight, which means there is no numerical value on the edges. Example 7. Textbook page 137. Draw a directed graph based on the given information. For this example, the vertex U appears in set V but not in set E. This means vertex U is not connected to any other vertices in the graph, and it is known as an isolated vertex. Solution: you have to list down all the vertex pair and direction. So after you list down, you can see that two edges from vertex P, one edge from vertex R, and three edges from vertex S. Vertex T is only connected to vertex S, and this will be the final answer. There is a loop at vertex Q and RS is a multiple edge such that solution, there are four vertices, so you have to write down all four vertices which are P, Q, RS, and RS a multiple edge, a loop at vertex Q, then you draw a loop at vertex Q and complete the graph based on the number of edges going into and coming out from each vertex. Then this will be the final answer. Example 8, textbook page 138. The diagram on the right shows one-way path that Izaru can choose for his running practice. Vertex V1 is the starting position and vertex V5 is the ending position. Before he goes home, determine the shortest distance from V1 to V5. From the diagram, you can see that the shortest distance is from V1 to V2, then you will reach V5, which is 1.1 kilometers. The longest distance from V1 to V5. The longest distance means you have to go through V1, V2, V3, and V4 and V5. And the answer will be 2.5 kilometers. The vertices that must be passed through if the distance of the one-way run is between 1.4 km and 2.1 km. The answers will from V1 to V2 to V4 and to V5, and the distance is 1.9 km. Another answer is from V1 to V3, V4 and V5, and the distance will be 1.5 kilometers. That's all for today. Thank you.